Hello and welcome to the first lesson on Unit 2 Thermal Physics. We're going to start by looking at states of matter. So our first learning objective for today is describe the properties of and structures of solids, liquids and gases. And in the second half of the lesson, we'll be describing the changes that take place when a substance changes state from, say, a solid to a liquid or from a liquid to a gas. So starting with the first learning objective, all substances are made up of particles. The particles are attracted to each other. Some particles are attracted strongly to each other, and others are quite weakly attracted to each other. The particles move around. They are described as having kinetic energy, so that's movement energy. The kinetic energy of the particles increases with the temperature. So if we start by looking at solids, they've got a high density. That means they're closely packed together, the particles. You can't compress them because there's not much space between them. They've got a fixed shape because the particles are held tightly together, and they can't diffuse because they're not able to move. Liquids, on the other hand, are quite highly or fairly dense, not quite as dense as solids usually, but more dense than gases. They cannot be compressed because there is very, very little empty space between the particles, and they take the shape of the bottom of the container because the particles can move, and they are also able to diffuse. And finally, gases. They're low density because there's huge spaces between all the particles. As you can see there, there's a big space there, so you can compress them, you can bring them together to make them closer. They've got no fixed shape because the particles move about rapidly in all directions, and they can diffuse because the particles are able to move in all directions. Okay, so quick task based on what we've talked about so far. I want you to fill in the blanks on here. So, for example, for a diagram for a solid and a gas, I've done the liquid one for you. The volume for a solid is fixed. Is it fixed for a liquid? Is it fixed for a gas? Give you a moment to think about it. Hit pause. I've also given you the answers all here. You just need to put them in the right place. So I'll give you a few seconds while you're pausing it. And now I'll put the answers on. Okay, I hope you did okay on those. And moving on, still continuing with our first learning objective. So which of these is going to be easier to compress? The lead block or the balloon? Well, I'm pretty sure you're all aware of the fact that it's going to be the balloon. That's pretty obvious. But why? It's because in the balloon, it's got a gas inside. And there's lots of space between the particles. The solid particles in the metal block are already very close together, so they cannot be compressed. So you can see there in the gas balloon, the particles are like that. You can squash them together, make the particles closer so they're easy to compress. Okay. Another question. This is brake fluid. Now, brake fluid is a liquid. Can I compress this brake fluid easily? Like I say, the brake fluid is a liquid. Give you a few seconds to think about that. And the answer is no. You cannot compress it. It's a liquid. It can't be compressed. But why is that important? Well, the reason it's important is the brake fluid is inside brake pipes in your car. And when your foot presses down the brake pedal, it then presses the brake pads and the brake discs together in the car. If it could be compressed, then what would happen is when you press down, it wouldn't automatically transfer to the brake pads and brake discs, and your car wouldn't stop. It could be a little bit of a disaster. So, next quick tasks. I've got 4 statements here about particle structure. There's a mistake in each one of these sentences. Give you a few seconds and think of what the mistake is. Okay, so the first one's pretty obvious. There are 3 states of matter that we look at. You cannot compress a substance in a solid state because the particles touch each other. The next one, in liquids and gas states, a substance flows because the particles can move from place to place. And you can compress a gas because the particles are spread out. A little bit of a harder task for you now. This is a past paper exam question from the UK specification, the 6-mark question. Unlike the Cambridge exams, it's not a case of 6 marks, means you've got to make 6 points. It's probably going to need to make more than 6 points to get full marks on this. So this is more of an essay style question. So what I'll do is, again, give you a few seconds to pause it, write out your answer and see how many of the bullet points you've got from the example answer I put on. Okay, so just going to put the answer on here. Again, pause it for a moment, see how many of these you've got. Okay, that is the end of the first learning objective, which was describe the properties and structures of solids, liquids, and gas. I hope you're all feeling okay with that. So moving on to our second learning objective, let's describe the changes that take place when a substance changes state. So this here is water. Sorry, this here is ice with water. And these are various different states of water. So here, like I say, we've got ice, which is solid, mixed with water, which is liquid. This is condensation, which is a liquid. This here is ice, which is a solid. And this here is steam, which is a gas. So you need to know the changes of the states. So from a solid to a liquid is melting. From a liquid to a gas is boiling or evaporating. And in a future lesson, we will look at the difference between boiling and evaporating. When we go the other way, when we go from a gas to a liquid, that is condensing. And then from a liquid to a solid is freezing. So here are some very quick questions on what we have just talked about there. Again, pause it, give you a few seconds to think. Okay, so the first one, which of these means a change from a liquid to a gas, that is evaporating? When ice melts, which of the following is not true? Which the mass decreases. Match the words to the relevant state change. So sublimation, now we haven't talked about that, but you can work it out through process of elimination. It's solid to gas. Freezing is liquid to gas. Condensation is gas to liquid, and melting is solid to liquid. And which two of these processes release energy? Again, this is something you can kind of work out. So when you release energy, you are changing from something which is high energy to something which is lower energy. So that would be condensing, where you're going from a liquid to a gas. So you're going from low energy liquid to higher energy gas. Sorry, got the other way around, sorry. That is when you go from a gas to a liquid, so you're going from high energy to lower energy, and freezing, where you go from a liquid to a solid, again, going from higher energy to lower energy. Okay, so that's basically everything we've covered so far. That's the end of the second learning objective. So what I'm going to do now is put on some past paper 2 questions. So these are questions from paper 2, the multiple choice section. This is related to both learning objectives. Again, I'll put each one on, give you a few seconds, and then put the answer up. So which statement describes molecules in a gas? Well, they are far apart and move about quickly. Next question. There are 6 in total. A scientist investigates 2 substances, P and Q. Substance P completely fills its container but can be compressed. Substance Q is not in a container, but has a definite shape. In which state is each substance? Well, substance P is a gas and Q is a solid. So it's B. Okay, next question. Which line in the table correctly describes whether the molecules of a solid, liquid, and gas are moving or stationary? Now, even though in solids, we've talked about solids being, having a fixed shape, they do vibrate about a fixed position. So the particles, unless they're at absolute zero, which is the lowest temperature possible, are always moving. So the answer is D. Question 4. The diagram represents molecules in 2 different states of matter. The arrow shows the motion of the molecule. What is state 1 and what is state 2? Well, state 1, you can see they're far apart and moving freely. So they are in gas. Whereas in state 2, sorry, you can see they've got they've got a regular pattern there. So that is a solid. So the answer here is B. Question 5. Which of the following correctly compares the force between the molecules in steam, water, and ice? So I'll give you a clue. They are more strongly held together in the solid state. Okay, so that means the weaker state is gas, the medium state is liquid. So the answer is C. And the final of the multiple choice questions, question 6 here. Substances can change from one state to another. For substances to change state from one state to another, there must be some energy transfer. Which change involves substances taking in energy and which changes involve the substances giving out energy? Okay, so energy is taking in, like I say, when you go from a substance with high energy, so from a substance with low energy to a substance with high energy, that is when you take it in, and the other way around for giving it out. So when you go from a substance with high energy to a substance with lower energy. So 1 and 2 are taking in energy, 3 and 4 are giving it out. So the answer is A for that one. Okay, so that is the end of the first lesson on states of matter. The next lesson in the series on thermal physics will be on gas pressure, so pressure in gases. I will be uploading that straight after this. Thank you very much, everyone. See you later.